question. So let's so eco according to the question, EcoR1 have generated 5 fragment 1, 2, 3, 4, 5. Okay, and BAMH1 also generated 3 fragment, and on double digestion it gives us 1, 2, 3, 4, 5, 6, 7 fragment. Okay, so what I have told you, that first consider the restriction digestion that gives you more fragment than the previous and then as compared to the other. Okay, so EcoR1 gives you 5 fragment, which is obviously more than the BAMH1 digestion, because BAMH1 digestion creates 3 fragment. So we have to consider EcoR1. So this is the 5 fragment of EcoR1. Let me draw it. 1, 8, another one is 7.4, another one is 6.2, 4.5, 2.9. Now we have to compare this band with the double digestion. So I have also drawn it here. So if you focus that, then you can easily find out a 6 and 2, that will gives you 8. So there will be a BAMH1 digestion site in the EcoR1 fragment generated and length 8 kb, right? And there is a fragment 7.4 which is also present in EcoR1. That means what? In that fragment there is no recognition site for BAMH1. Okay, and there is again a 6.2, and here is also 6.2. That means there is also no recognition site for BAMH1. And there is again a 2.9, and here is again a 2.9. So there is also no BAMH1 site here also. But in case of 4.5, you cannot find any kind of 4.5 in EcoR1 BAMH1 double digestion, but you can find 3.5 and 1. So that we can conclude in the 4.5 fragment there is a restriction site for BAMH1. So we have successfully isolated all the restriction site. Now we have to construct the map. Now we need to consider the combination, so that we can construct a map that will fulfill all the information. So now we need to consider the combination, so that we can fulfill the information that they have provided us. So for fulfilling the combination, I have told you that you need to focus on that BAMH1. So there is 3 fragment, 12.9, 10.1 and 6. Okay, so we have to keep it in our mind. So we have already find out the 6. Okay, so we have to combine all the fragment in such a way that the remaining fragment will gives us a 10.1 and other remaining fragment will gives us a 12.9. So if you add it first, then you will, if you join it with a 7.4, then if you add 3.5 here, then what you will get? 3.5 plus 7.4, that means 10.9, and then plus 2, that means 12.9. That means you have now your one fragment of BAMH1, and the rest will give you 10.1. that is 1, 2.9. 2.9 and 1 means 3.9. 3.9 plus 6.2 means 10.1. So this part gives us 10.1, this part gives us 12.9, and the rest gives us 6. So we have successfully constructed the map, and as here the question tells us that the DNA molecule is linear DNA molecule, so our answer will be completed here. So what are the basic steps that you need to follow to answer any kind of restriction mapping problem? First of all, by reading the question, you have to find out all the fragments that was generated by single digestion and double digestion, and by then the step 2 will be you have to calculate all the fragment length in each cases, so that you can find out whether is there any kind of problem in the question, or you have made any kind of mistake or not. So if all the fragment length is same, then you can conclude that yes, the question is also right and I have not made any kind of mistake till now. The third step will be find out the restriction digestion that gives you more fragment than the another one, and here the comparison will be in between the single digestion. Okay, so here EcoR1 gives us 5, BAM-H1 gives us 3, so we have to consider the EcoR1. The fourth step will be EcoR1 then compared with EcoR1 BAM-H1 to find out the restriction site for BAM-H1 in the EcoR1 generated fragment. Once we find out, now we have to use combinations to form the 12 the fragments generated by another restriction digestion that we have not choose for comparison with the double digestion, and we will get our result. And if they tell us that it is a circular path bit, then we have to join the two ends simply to get us to ultimately construct the circular map. That is what restriction mapping problems are. Okay, so I have not discussed about any kind of double digestion problems. Okay, but those are also important. Okay, no, sorry, I have not discussed any kind of triple digestion problem, but they are also important. You need to know about triple digestion when you are appearing for CSIR NET or GATE. But if you are a university student, then up to this problem your knowledge will be enough to solve any kind of problem. Okay, so till then, bye bye.